Rajat, I am going to present on the impact of learning UMLS knowledge embeddings in relation extraction from biomedical text. It was presented in Jamia Journal of American Medical Information Association in 2020. So first, let me tell about what is knowledge embeddings. It is the representation of concepts and relations encoded in the knowledge graphs. And also one of the definition that would be used later is lexicalized knowledge embeddings, which combines the lexical knowledge with the semantics available in the UMLS meta thesaurus. It does so by preferring the term associated with each biomedical concepts. And in this paper, the authors have used Bluebird, which is a relation extraction system pre-trained on PubMed abstracts and clinical notes from Mimic 3 datasets. So, what is the objective of the paper? It is to explore how knowledge embeddings learned from the UMLS meta thesaurus impact the quality of relation extraction on two diverse sets of biomedical texts. So, in this paper, authors learn two forms of knowledge embeddings, which are lexicalized knowledge embeddings and unlexicalized knowledge embeddings, which we will call UNLKE. So, in this first, what we are doing is we are learning the knowledge embeddings from the UMLS. Then we are incorporating it in Bluebird, which is a relation extraction system, and we are calling this system as Reiki, which is relation extraction from knowledge embedding system. And then we are evaluating the impact of this knowledge embeddings learned on two diverse sets of biomedical texts. So first, let us see what are some of the related works of relation extraction. In the past, authors have used classification method to extract the relations. The winner of I2V2 2010 datasets, authors have used support vector machines, while some authors, to account for local syntactic information in text, have used CNNs, while other authors have used hierarchical RNN or graph convolution networks, but they rely on syntactic information from dependency parsing. But currently, the state of the art system is Bluebird, in which the authors showed that deep contextual information is more impactful than syntactic knowledge. But in that, the authors did not exploit the UMLS meta thesaurus, due to which this authors in this paper are proposing to do so. So what are the drawbacks of the previous system? So one of the drawback is the biomedical concepts can be mentioned in various ways in biomedical concepts. So how the authors resolve this issue is by introducing lexicalized knowledge embeddings and to account for different types of concept mentioned as well as relation types. This can only work in lexical knowledge system, while when using unlexical knowledge embeddings, they address this issue by performing entity linking from a concept mentioned to the concept encoded in the UMLS and retrieving the knowledge embedding for the linked concept. What is the next issue? It is that new relation types between mentions of biomedical concepts are not encoded in the UMLS that could be of interest. For example, there could be a new relation that is formed between two entity types. For this, they have designed Reiki, which is a relation extraction using knowledge embeddings that incorporate this LKE or an unlexicalized knowledge embeddings in the Bluebird system by scoring the plausibility of the relation types of interests. In this, authors have used two relation extraction dataset, which is 2010 I2B2 dataset and 2013 drug-drug interaction extraction challenge corpus. So let us know more about the I2B2 2010 datasets. In this, the medical discharge summaries and progress notes were annotated, and there were three kinds of medical concepts that were mentioned, which is problems, tests, and treatments. And there could be 8 types of relations between them. So what happens when there is a problem, treatment, and a test? Sometimes it's not always possible that for a problem a particular treatment works. So sometimes the treatment improves the problem, while sometimes it deteriorates the problem. And similarly, to detect a problem, there is a test that happens. So similarly, there are different types of relations that are there. So in this, in the training set there were 170 documents, whereas in testing set 256 documents. So the authors in the testing set, uh, so the annotation of the concepts were there in the testing set, whereas only the relation annotations were well held. Also in the training set there was 16,000 concept mentions, while in testing 31,000, and in training set 3,000 relations were annotated, whereas in testing set around 6,000 relations were need to discover. The second dataset that was used was drug-drug interaction corpus, in which there were 4 types of pharmacological substances, whereas 4 types of DDI, which were relations, and it also consists of 2 data set. The drug bank data set, which consists of 792 texts and 15,756 substances, whereas in Medline abstracts there were 233 abstracts consisting of 2,000 substances. So this is the example of the relations and the concept mentions, which is drug, brand, and group. Now we will come into the relation extraction using the knowledge embeddings. So in this they have used Bluebird, which is I told you previously. So first let's consider this knowledge embedding encoder. For now we'll consider it as a black box. So whenever there is a sentence from the biomedical text and the relation types, it is fed into the knowledge embedding encoder, which takes the help from the UMLS to get the embeddings EAM, EMB, and all the relation embeddings. But before these embeddings are concatenated from the context embedding of the Bluebird H, they calculate a score SAB, which is a trans-T score, and they have from the previous works they have experimented that this trans-T score is better, and after that a softmax function is used after concatenating these scores and H to get the relation R. So before going into the knowledge embedding encoder, let's see what the previous authors have used. Some authors have used Rascal, which uses knowledge embeddings using matrix factorization, while others produces translation based on knowledge embeddings while others in trans T they have extended trans E by dynamically projecting the concepts and relation embeddings in various spaces. So in trans E, the concepts and relation embeddings are all in this one space, while in trans T they are in multiple spaces. Previous authors have also proposed dismult, which simplifies Rascal by using diagonal matrix, whereas in KB GAN it uses adversarial learning to generate the knowledge embeddings, while in this paper they have extended KB GAN to increase the accuracy. So we all know how a GAN works. There is a generator and a discriminator in which both competes against each other. The discriminator, it learns to score the relation plausibility between the pairs of UMLS concepts, while generator tries to fool the discriminator by generating plausible yet incorrect relations. To accomplish this goal, given a concept Ci, generator selects a set of negative samples negative examples of samples connecting the concept Ci to other concepts from the UMLS by computing a probability list. Then the discriminator sends a reward G reward by comparing the negative sample to the one encoded in the UMLS. Eventually, the discriminator learns not to be fooled by the generator. So in this diagram, we can see that lexicalized knowledge embeddings are on the left side, whereas unlexicalized knowledge embeddings are on the right side. The top part is the concept mentions, whereas the bottom part is the relation type encoding. So what happens is when a UMLS, so to capture the meaning of the name, word piece tokenization on the preferred atom of each biomedical concept Ci is encoded in the UMLS. Then word piece tokenization are being further processed by the language model, in this case which is a BERT, to capture the deep lexicalized context. The multiple tokens from the language model are passed through a span encoder, in this case which is a BioLSTM, to generate the single encoding S prime. When learning the probability distribution, generator used dismult scoring function while the discriminator used the trans T scoring function. This is so like in that's why it is this knowledge embedding encoder is learned, but it can only be used for the words encoded in the UMLS. But while for the words not encoded in the UMLS, they used an additional side-spacey entity linker to link the entities to the UMLS. Otherwise, this Reiki system is same, it's just from a different angle. So like these entities, they are going into the bluebird, from here they are going into the knowledge embedding encoder, then their scores are calculated, and from here contextualized embeddings and the scores are concatenated to get the softmax, to get the relation. So now we'll come to the results and we'll see the train test split of all the relation counts between the I2B2 data set and the drug-drug interaction data set. These are the results. So in this we can see that when the Reiki system was after incorporating with the lexicalized knowledge embeddings, the accuracy was improved 2% in the precision, recall and F1 score. And these are the fine grained results according to the relation types. And this is an example after comparing it with the bluebird. So in this example, as you can see that however, due to the episode of bleeding on post-operative day 2, the Coumadin was held for 2 consecutive days. So while the bluebird, it uh, incorrectly classifies as TRP, while the Reiki correctly classifies it as a TRNAP.